So, this module we are basically going to be seeing another tool that is actually used for detecting any kind of intrusions on the network, right. So, this tool is basically called as Snort, and this tool is also very powerful, and it has been actually in use for a long time as part of any kind of a network security auditing mechanism or a network security prevention of any kind of attacks as well. So, we will take a quick understanding on what exactly is intrusion detection initially. So, intrusion detection is basically defined as a problem of identifying individuals who are using a computer system without authorization, right. So, we will just try to explain this definition of an intrusion detection from the back. So, without authorization, any system actually has an authorization to validate the user who is trying to make use of the system. So, if it is basically an OS, we have a login mechanism typically first where we will have to log in, right. Only after the login credentials has successfully been given, the system, the OS is actually going to recognize this particular user to be a valid authentic user, right. Similarly, if it is a network device like a router or a switch, I might have to give a password to validate myself, saying that okay, I am actually a valid user, right. Now, when somebody says he is the user without authorization, we actually have a name called as a hacker or a attacker for him, right. Now, when it comes to hacking, there are two categories here, one who is an ethical hacker and one who is a attacker who basically has a sole intention of trying to bring down a network server or a network service, or for that matter even the entire network, right. So, ethical hacker is somebody who is actually performing an audit of how secure a network is, and at the end of it he will basically be giving a report so that the administrator can basically take some preventive actions for the network to be attacked by any unauthorized persons, right. So, that is basically what we are referring to here as a person without authorization, right. Now, the purpose of this is we want to identify any kind of a person who is actually acting as an attacker and trying to use any kind of computer resource like maybe a system, or trying to attack a network device like a router or whatever it is without authorization, right. So, without trying to authenticate himself and certifying that he is actually a valid authentic user, anybody who is trying to basically bring down a particular server or a system or a network is basically has to be identified, and the entire process of identification of these kind of attacks is what we are referring to here as intrusion detection, right. Now, we will have to identify and sort of differentiate intrusion detection with intrusion prevention, right. Now, intrusion prevention is a preventive mechanism that I actually try to employ after I start doing an intrusion detection, right, over a period of time. So, over a period of time I sort of build my knowledge database in sort of detecting intrusions, and based on this knowledge database that I have, I put in mechanisms in place so that any future intrusion that could happen can be prevented itself in the first place, right. So, if I have to basically give a very simple representation of intrusion detection versus intrusion prevention, intrusion detection is a sort of a post-mortem analysis after the intrusion has happened, right. I take some corrective mechanisms so that I try to find out first maybe what kind of data has been compromised, and secondly apply that understanding for me to effectively stop any kind of intrusions later on, right. Whereas intrusion prevention is a preventive mechanism before the problem is actually trying to happen, right, before the problem of intrusion is really trying to happen. So, when somebody talks of intrusion detection, we will have to be very careful in understanding that we are not going to try to prevent an intrusion when we are talking of an intrusion detection, right. So, these are actually two different aspects, and there is a very high possibility that we might be getting confused between the two of them, which we will have to be very careful of when we are talking of intrusion detection versus intrusion prevention, right. So, successful intrusion detection will basically depend on what is the kind of a security policy that I really have, right, and also what kind of management of my network as well as security that I am employing, right. So, on both these factors it is going to be very much dependent on as well as what is the kind of technology that I am using, right. So, essentially if I basically have let us say my management tells that there is not enough money for budgeting on deployment for network security related purposes, I am basically going to have a very weak intrusion detection mechanism in place, because of which there is a possibility that I could be attacked very easily by an attacker outside my network, right. Secondly, it also depends on the policy, where as part of my business requirements, if I can for example say that I want only very minimal access to be allowed from externally, I could actually block lot of things, because of which the possibility of an attack itself is very limited. But on the other hand, if because of my specific business requirements I need to allow lot of traffic coming into my network from outside, then I also need to put in place lot of restrictions as part of my security policy, because the security policy in turn is governed by my business needs, right. So, I need to put a lot of restrictions in my security policy, because of which my tools deployment and the kind of performance that I might be getting out of the network traffic might become extremely limited, because we will have to understand the more stringent security policy that I try to deploy for my network, it is actually mutually contradictory with whatever amount of performance that I will be getting, right. So, for example, if I as part of security put lot of rules to be checked in, right, and I specify that I do not want any packet which is violating those rules to be allowed inside or allowed outside of my network, then for each and every packet that is going through my device, right, my security device, all those rules have to be checked in, right. So, more the security policy, stringent security policy, more number of rules that is there, more number of rules that is there, that many more checks that I will have to do for every packet, more the amount of checks that I will have to do for every packet, the packet is going to take that much more time for it to either get out or get inside my network, and that is going to have a direct bearing on the amount of latency that my application at the end user level is going to be facing, right. So, security policy depends on a whole plethora of factors, and this has to be actually be sort of finalized and addressed for me to come to a conclusion on what kind of detection mechanisms that I will have to deploy. And then the next factor is notification, right. So, how quickly I am going to recognize and detection, and who is it that I am going to be monitoring, and who is it that I am going to reporting to. So, that again is basically part of my policy definition, which I will have to basically define as part of my rules. And then once I have detected that there has been an intrusion, how is the entire response to that detection going to be coordinated, right. So, because if I detect that there has been an intrusion, I will have to take some actions. Now, for each of those actions, who is going to give an approval in my organization, in my network security organization, how quickly that person is expected to respond for that approvals, all those comes under as part of the response coordination, right. So, all these is basically parts of my security policy that I will define, right from the point of view of what kind of traffic I am going to allow or deny based on the business requirements that my organization is currently in. And once I detect an intrusion, how am I going to notify, who am I going to notify, how quickly am I going to notify. Thirdly, once I have notified, how is the entire response to the detection, intrusion detection going to be coordinated. So, what is Snort? So, Snort is basically a multi-mode packet analysis tool which could actually act as a sniffer, right. So, it could actually sniff the packets, then once it has sniffed the packets, it could also do a packet logging mechanism. Once it has logged the packet, it could also do a packet data analysis tool on what kind of data is actually getting transported on those packets. Once it has done the data analysis and the logging, it could then try to apply the network intrusion detection system principles and sort of identify packets that is basically creating possible problem if it is actually allowed inside the network, right. So, we will have to understand sometimes there could also be a false positive or a false negative, because all these are governed by certain rules and configurations that are applied and has been predefined, right. So, sometimes those rules or configurations could also be resulting in flagging a false positive case, wherein the packet cannot be really considered as an intrusion, but because of it matching certain rules that has been specified, it is reporting it as a positive case to be flagged as an intrusion, right. So, there is also certain possibilities that is there, but the attempt on the maturity of my intrusion detection mechanism will always be to ensure that the amount of false positives that the tool is reporting, that my specific tool installation is reporting, is kept to the bare minimum possible extent, right. So, it has been developed basically for a need to perform network traffic analysis in both real time as well as doing a post-mortem analysis for any kind of forensic analysis, right. So, I want to do a post-mortem analysis of the network after, let us say, it has been attacked, right. So, I need to do a very quick analysis of the kind of different packets that has actually come in just before the attack, and among those packets I want to quickly identify which of those packets could have been the culprits, which could have been the result by which this attack had actually happened, right. So, I could use this basically for doing that analysis also, right. So, with respect to the different metrics on the Snort implementation, we will have to understand that the code is actually not very huge. It is actually customizable depending on the kind of features that we require. We could also limit the amount of code that is actually used for building the product. It is extremely portable because any kind of common platform that you name today, or it is in very popular use, any kind of operating system that is in common use, I have this software available on that, right. So, in that way it is extremely portable. It is very fast because it could actually operate on 100 Mbps networks, and it could also operate on a gigi networks as close as possible to the line speed, right. So, I would not say that it will operate on the line speed, but it is extremely fast from the time with respect to the time that it is actually taking for doing the processing on a per packet basis, right. So, it is extremely configurable again. So, as I was telling, I could essentially say what kind of packets I want to be really looking at, what kind of rules I want those packets to be satisfied before it is marked as a possible intrusion packet, undesirable intrusion. I could actually have configuration done for different kinds of reporting and logging mechanisms for the captured packets, and most importantly it is a free software that I could actually take, download, customize it, use it, and then also very importantly, if I have the capability and the technical skills, I could also go ahead and modify and then enhance it to suit my own requirements, and subsequently submit my enhancements also back to the open source community. So, this is basically governed by the GPL license. So, essentially it is a packet sniffing lightweight network intrusion system that we were discussing right now. It is based on the LiPCAP sniffing interface, very similar to the Wireshark that we were actually discussing in our previous module. It is a rule based detection engine. So, as I was telling, I will be specifying a certain set of rules that every packet that is coming into my network will be subjected to, and as long as any packet is matching any of those rules that has been specified, that packet will be actually flagged as a intrusion detection packet that needs to be analyzed separately, right. So, I could also have different plugin modules on top of the existing base implementation, which could be very much customized to my specific detection requirements or my own customizations on the basic functionality or whatever. So, this is basically the one of the main reasons why this is actually a very customizable and a pluggable software, and because of this, this has actually become a very common intrusion detection softwares even in a lot of commercially available security products in the market today. So, as far as the detection engine goes, I actually have a rules based detection engine. So, what we call as a signature. So, signature is nothing but a particular pattern that I expect to be seeing in the incoming packet, and the moment I see the same signature pattern on the incoming packet, that packet will actually be flagged for an analysis to be done with a tag saying that this packet specifically looks to be like an intrusion packet from an unauthorized user, right. So, I could really do a very wide range of detection capabilities. I could find actually a stealth scan, I could do a OS fingerprinting packet that is being attempted, I could do an analysis detection of the packet of a buffer overflow, any kind of most of the backdoor entries that are possible and so on and so forth, right. So these are the different typical kind of initial attacks that attacker would try to employ to get access into the network, number one, and number two, once get access into the network to find out more details about each of the devices in the network. For example, the OS fingerprinting, as we were discussing in the earlier modules on network security, it basically tries to find out what is the OS that is running, not specifically what is the OS alone, but what version of that OS is running, right, because with that kind of a detail I will be able to quickly come to a conclusion on what kind of possible loopholes or compromises are there in that particular OS and in that particular OS version, which the attacker will try to make use of and try to bring down the system, right. So all these kind of things could be detected by putting in the signatures for these different kinds of packets as part of the rules. So once it is put as a rules, every packet that is being attempted to enter inside my network through the Snort will be subjected to this comparison, and if the comparison matches, that packet will be silently flagged saying that this is possibly an intrusion packet that is actually coming in, which needs further analysis, right. So that is basically what the detection engine, which is the core part of my Snort IDS, is actually doing, right. So there are a lot of plugins that are possible, as we were discussing in the earlier slide. So I could really have a preprocessor plugin wherein I could actually have a newer packet which I would like to be examined or analyzed before being handed to the detection engine. So if I want to make any kind of modifications on the incoming packet before the detection engine picks it up, I could do it as part of the preprocessor. Then I could do lot of customizations as part of the detection, and once it is detected, if it is matching any of the rules, I actually could have the output reported by my own customized plugin in a particular format or in a particular specific output medium or whatever it is, right. So all these are different types of plugin at different levels of the packet capture and my detection capabilities that the Snort is providing me. So all these are basically customizations that I could really do. So in terms of the uses of Snort, I could effectively do a packet sniffing, network intrusion detection. I could do a policy enforcement based on a security policy that the organization has defined, like how we were discussing initially, or the background requirement for the IDS, and I could also do a detection of the scan and any kind of an inbound trap that is actually coming in, right. So three main operational modes. One is a plain sniffer mode, second one is a packet logger mode. So in a sniffer mode, I will just sniff the packets and then display it. In a packet logger mode, I would also sniff the packets, along with that I will go and log the packets in a particular format and in a particular medium. And in a NIDS mode, my detection engine also parallelly runs, wherein I will be able to do the detection, comparing it with the signatures that are there as part of my rules engine, right. So all these operational modes, whatever I want to run for the Snort, are typically configurable in my configuration file or via command line options when I try to bring up the application, right. So sniffer mode, it basically works like a TCP dump application where it just decodes the software and dumps them. So it does not do anything else, right. So the dump will look something like this. It is just an example dump that has been given, where I could just get the headers because basically the TCP dump application is running in the backend for this, and the output from TCP dump is simply captured and then displayed into your standard output device, which is typically by default your terminal window. So in a packet logger mode, I could actually take the packets and then store it onto disk, and I have different types of logging options where I could just dump it into a normal ASCII file, normal ASCII text file. I could dump it in a TCP dump format, I could dump it in XML, I could dump it in a database specific format in a specific database, and so on and so forth, right. So once I dump it in this manner, separately I might have other tools to do an analysis of it to detect any kind of suspicious activity of the packets through the packets that has actually come in the network, which has been captured in this packet logger mode. So in the NIDS mode, apart from the sniffer and the logging part, I also do the analysis of the traffic then and there and try to do the detection of any kind of an anomalous activity straight, right. So in that way I will get some real time inputs, and as long as I have an effective reporting mechanism of reporting any kind of a suspicious activity, I will be able to quickly take some corrective action hopefully, and then sort of prevent from extreme damage happening, right. So, whereas in a packet logger mode I could only do a post-mortem reactive analysis and sort of prevent any kind of attacks in the future. In the NIDS mode, as long as I have effective logging and a reporting mechanism including who and how the action should be taken on the NIDS reporting any kind of possible suspicious traffic, I will be able to stop from the attack getting to be in a severe damage mode, right. So, even if the attack happens, I will be able to react to it quickly and then sort of prevent any kind of very severe action, right. So, again in the NIDS mode there are lot of different options that are actually available for dumping the output once it has actually identified specific traffic, which could actually be used for the final analysis, and then the input from this analysis, as we were discussing, could go in as part of my updated rules engine, so that any kind of a subsequent attack, a similar subsequent attack in the future could be prevented then and there immediately, right. So, this also helps me into sort of getting from a network intrusion detection mode into a intrusion prevention mode over a period of time in the future, right. So, we have actually seen a couple of sample network security products like Wireshark and Snort, just to give us an idea on what kind of things are possible. Likewise, there are so many tools that are actually available with which we will be able to deploy these tools in different parts of my network to effectively try to ensure that the network is protected from different types of attack. And then secondly, even if the network is attacked, there is a possibility that I will be able to quickly recover from the attack without a major chunk of my network getting affected, right. So, we just saw a couple of examples of the tools that are very commonly used, but likewise there are so many other tools that are possible to be used, and this was just a sort of appetizer and to sort of give you a basic idea on what kind of tools are very commonly used as part of network security, right. Thank you.